Welcome back. Now let us see how we can find the equation of the tangent in part A using method 2. So method 2, that is the method of the perpendicular lines. So part A, which is given as x squared plus y squared plus 6y minus 1 equals to 0. And the point of tangents in this case is 3 and negative 4. When you're using method 2, that is the method of considering perpendicular lines, we need to sketch the circle to guide us. So I sketch the circle, then I assume anywhere the point of tangency, then I assume it down to for us to easily visualize it. This is the point of tangency, which is on the circle here, that is 3 and negative 4. So let me call it point A to simplify our work. And the point from where the tangent comes, let me call it point B. This is the tangent. Now, what do we need? We need the coordinates of the center of the circle. And this is the radius from the center to any point on the circumference. In this case, the point of tangency. So, they make right angles here. Now, this is the radius. What are the coordinates of the center? If you look at this equation in the expanded form, you can go on, compare the equations and coefficients, and then you get the coordinates of the center. But in this case, if you have practiced, the coordinates of the center are 0 and negative 3. These are the coordinates of the center, 0 and negative 3. Now, what do we need to do? We need to find the gradient of the radius so that it can assist us in finding the equation of the tangent. So, finding the gradient of the radius, which is a line. Now, we have 2 points on the radius, which are the end points of the radius. That is point C, which is the center, 0 and negative 3, and then the point of tangency that are called A, which is 3 and negative 4. If you have 2 points on the circle, you can define the equation of that circle. So, if you have 2 points on a line, please, if you have 2 points on a line, then you can define the equation of that line. Now, let us do the gradient of the radius n, which is given by changing y, which is y2 minus y1 out of x2 minus x1 equals to, then you come in points x1, y1, x2, y2. Then you substitute y2 is negative 4 minus y1 is negative 3 out of x2 is 3 minus 0. Then you place the calculator so that you get the value of the numerator. Negative 4 minus negative 3. I'm getting negative 1 over 3 minus 0 is 3. So that is the gradient of the radius. That is the gradient of the radius. But what do we know? We know that the radius r is perpendicular to the tangent AP in this case. So, but the radius is perpendicular to the tangent. What does that mean anyway? It means that we need to apply the concept of the gradients of two perpendicular lines, which says that the product of any two perpendicular lines is negative 1. That implies that the product of the gradient of the first line times the product of the gradient of the first line and that of the second line equals to negative 1 as long as they are perpendicular lines. So let me consider the gradient of the radius as m1, so that this now becomes my m1. So that is my m1. Now we need to substitute for n1, which is -1 out of 3, and 2 equals to -1. What is the value m2 in this case? Therefore, m2 here becomes positive 3. Positive 3. This is now the gradient of the tangent to the circle. Therefore, gradient of the tangent equals to 3. If we know the gradient of the tangent and we know the point of tangency, that is the point on the circumference, which is for both the radius and the tangent, then we can find the equation of the tangent. How? We have the point of tangency, which is for both, that is point A, 3 and -4, and then we have the gradient of the tangent, which is in this case m2 is 3. So we apply the equation of a straight line. The tangent is a straight line. So therefore, our y is given by mx plus c, where c is the y-intercept. That is the point on the y-axis when the tangent cuts the y-axis. So substitute this is x, this is y, this is m, so that we find the y-intercept c. Therefore, we shall have a -4 equals to m. M is 3 times x, which is 3, plus c. If you work out, you find that c equals to -13. That is the y-intercept. Therefore, you come back and substitute for only m and c. So that we have y equals to m. M is 3, x plus c. But c is negative. So minus c, which is 13. So this is now the equation of the tangent to the circle at the point of tangency 3, -4 using method 2.